Construct a stem and leaf. So to construct a stem, you're gonna create two columns over here. So is a stem, this column is a leaf. So you can write that for them. This is your stem. And over here, so is your leaf, a stem and leaf. And then looking at it, it go from 10 to 75. So what we can put is 1, 2, 3, 4, 5, 6, 7. All right. Now, how many of them? So let's go with this one now. We realize that you have, let me want to space this a little better. So how much go with the one? You have 15, you have something with 16, 18, 18. Then now with twos, you have 20, 21, 22, 22, 22, 25, 28. All right, we don't even know what this data represents, but we just plot in the stem and leaf. Then now with threes, we have 30, 30, 32, 35. That's it. With four, we have 40, 41. That's it. With 50, we have 52, 54, 59. Here, so we have 60, 65, 68, and we have 75. That round it out. Make sure we have all the data. This is 1, 2, 3, 4, 5, 6, 7, 8. It should be 24 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So the stem and leaf is correct. Then you can just give them a key. Always give them a key. So go tell them our key is tell them so this represents 10. All right. I don't even know what the data set is, so I just have to call it 10. 1, 0 represents 10. All right. So that's the key. Maybe if you want, you could tell them that something like 1, 5 represents 15. All right. Okay. So give them the key. It's a state and advantage of using stem and leaf to represent the given data. So stem and leaf, it is well organized, and so we are able to find mean, we are able to find median and mode very easily. That's the advantage of it, all right? Because the stem and leaf diagram, it is easy to find the measures of central tendencies known as mean, median, and mode. So it says determine the mode. We'll look at it and see which one occurred the most. You see 2, 2, 2, yeah, so you see a lot of 22, right? So 22 is the mode. So the mode is 22. They want us to determine the median. The median is the score in the dead middle. The median would occur at a half of the 25th position, which is 12.5. 12.5 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the median is 30. Median is 30. We don't even need to work it out. Median is 30. Then it says to determine the interquartile range. So the interquartile range, we need to find the lower quartile and the upper quartile. All right. Now the lower quartile, so if we're separating the data in half, all right, so the first 12 stops here, and the next 12 go here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looking at this first half, the term in the middle is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Term in the middle is between the 6th and the 7th term. All right, that's how we find the term in the middle, or some people would say a quarter of 25. And so the term in the middle is between 6 and 7, which is 1, 2, 3, 4, 5, 6, 7. So it's in between here. In between here and here is 21.5. So the lower quartile is 21.5. So the lower quartile is equal to 21.5. How did I know that? The lower quartile is in between here and here. In between here and here. Let's find the upper quartile now. So to find the upper quartile, it's going to be 3/4 of 25, which is the 18th and 3/4 term. So really and truly it's between the 18th and the 19th term. This is 13, 14, 15, 16, 17, 18. So between the 18th and the 19th term is these two. And so the upper quartile, that looks like 50. Is that 53? Yes, 53. So the upper quartile is equal to 53. So now we can find the interquartile range. I like to call it IQR. IQR, interquartile range, is the upper quartile 53 minus the lower quartile. And the lower quartile we found was 21.5. We do their differences. 53 minus 21.5, 31.5. Nice and easy. Soft. And that's it. 53 minus 21.5, that's 31.5. Nice and easy. Softy, softy, soft. Now part B. Part B says that two events A and B are such that the probability of A is 0.5, the probability of B is 0.8, the probability of A union B is 0.9. And it says calculate what is the probability of A intersect B. Now there's just a simple formula to do this. The probability of A intersect B is equal to the probability of A plus the probability of B minus their union. The probability of A plus the probability of B minus their union minus the probability of A union B. That will give us the intersection. So that's a simple formula to remember. So let's apply that formula right here. So we're going to get the probability of A intersect B. That's going to be equal to the probability of A, 0.5, plus the probability of B, 0.8, minus their intersection of 0.9. Not their intersection, their union. So we have 0.5 plus 0.8 minus 0.9. So 0.5 plus 0.8 minus 0.9 is 0.4. So that's the probability of A intersect B, 0.4. Now they want the probability of A given B. The probability of A given B, probability of A given B is actually equal to the probability of A intersect B over the probability of B. That's conditional probability. No, that's equal to probability of A intersect B, which is 0.4, over the probability of B of 0.8. 0.4 over 0.8 is a half, known as 0.5. That's the probability of A given B. It's a state given reason if A and B are independent, yes or no. They are independent if the probability of A times the probability of B is equal to the probability of A intersect B. So let's work it out. The probability of A times the probability of B is equal to the probability of A is 0.5 times the probability of B of 0.8. That's equal to 0.5 times 0.8. That's equal to 0.4. Also, the probability of A intersect B is equal to 0.4. And so yes, A and B are independent events. Nice and easy. They're independent events since the probability of A intersect B is equal to the probability of A times the probability of B. That's why they're independent. Nice and easy. Soft. All right, final part of this easy statistics question. They say a bag contains 3 red balls, 4 black balls, and 3 yellow balls. 3 balls are drawn at random. Find the probability that the balls drawn are all the same color. So the probability of the all the same color is, so the probability of getting same color. Why didn't I start the question up there? Yeah, I don't know why I like to write. I don't like these small lines, so I'm gonna write down here. Probability of being the same color is equal to the probability that you draw 3 red balls, or it can be you draw 3 black balls, or it can be that you draw, where you can draw 3 black balls, or you can draw 3 yellow balls. All right, that's the probability you draw the same color. Nice and easy. So let's look at how realistic this is now, which is the probability. The probability of drawing red, red, red. So to get red, then red, then red, you have 3 red. So the probability of getting the first red is 3 out of 10. But then after you take out a red, you're left back with 9 balls. So it's times 2 out of 9 to get the second red, times the probability of getting the last red is 1 over 8. Plus the probability of getting black, 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 it's 4 out of 10 to get your first black, times, if you take out 1 black, you're left back with 3 black out of 9 balls, times, if you take out another black, you're left back with 2 blacks out of 8 balls, plus the probability of yellow, yellow, yellow. Now you started out again with 10 balls in the bag, and so 4 yellows in there, so the chance of getting a yellow is 4 out of 10. Now given that you take out a yellow, there's 3 yellow left in the bag, and there was 9 balls, so it's 3 out of 9. Times, when you take out this yellow, you only get left back with 8 yellow balls. All right. Wait, it wasn't 4 yellow, it started with 3 yellow. My apologies, so this should be 3. It didn't start with 4 yellow, it should be 3. Started with 3 yellow. Then you take out a yellow, this would be 2 yellow. And this would be 1 out of 8. So we work that out. That would be the probability of getting the same color. So 3 over 10 times 2 over 9 times 1 over 8 plus 4 over 10 times 3 over 9 times 2 over 8 plus 3 over 10 times 2 over 9 times 1 over 8. That works out to be 1 over 20. 1 over 20. So that is a chance of getting the same color. So there's a 5% chance you'll get the same color. Very unlikely. So the chance of getting the same color is very, very slim. There is a 5% chance realistically of getting 3 same colors. Full stop. I know I wouldn't. All right, just to add some fun to it, you're telling them that I definitely wouldn't put my hand in the bag and take out 3 red or 3 black or 3 yellow, a matter of fact. I just wouldn't. I'm just not that lucky. All right, so have a sense of humor and tell them that. Nice and easy. Question 8. Question 8 goes now to say a motorist starts from a point X and travels 100 meters due north to a point Y. So the motorist travels 100 meters to a point Y at a constant speed of 5 meters per second. He stays at Y for 40 seconds, then travels with a constant speed of 10 meters per second to Z. On this following grid, draw a displacement time graph. Now, very good question. Why do I say that? It tells me that him travel 100 meters, traveling at 5 meters per second. Now, speed is equal to distance over time, all right? And they don't give us the time. So if you switch it, you get that the time is equal to distance over speed. Distance over speed. So that means 100 divided by the speed, which was 5, is 20 seconds. So that means it takes 20 seconds to travel the first 100 meters. All right, so this here says a S, and this here says a 5. And no, there's no distinct difference, but this is S, this is 5. So it takes 20 seconds for him to travel the first 100 meters. Then it takes him 40 seconds to stay at Y. Then he travels at a constant speed at 10 meters per second for 200 meters. So again, we need to work out the time for the last part of his journey. And the last part of his journey, the time is going to be equal to the distance of 200 over the speed of 10. 200 over 10 is 20. So 20 and 20 is 40 and 40 is 80. So the total time he's been traveling for is 80. So look how we're going to break it up. 10, 20, 30, 40, 50, 60, 70, 80. So it says that at first, he starts at the point X. Starts at X, can call that point X. And he travels 100 meters from X at a constant speed of 5. So this is 20. All right, how I want to draw 100. Well, how I want to scale it, because 10 and 200 and 100 is 300. Let me see how I can scale it. All right, how do I scale it? Let's say 25. No, I don't want to scale it like that. I want to get the scaling absolutely spot on. 20, 40, 60, 80, 100. Let's say here is 100. I'm going to go with here is 100. This is 100 meter. All right, I just want to get the scaling right. So the first 20 seconds, you travel 100 meters. So this is this now. After him travel this 100 meter in 20 seconds, he gets to his destination Y. So this is his destination Y. And it said him go and chill at Y for 40 seconds. So while he's at Y, he might travel for 20 seconds. After traveling for 20 seconds, he need to stop. Oh gosh, he's unfit. So 20, 30, 40, 50, 60. 60 is here, so. He stays at Y for 40 seconds, all right? So he's still at Y now, just stay at Y for 40 seconds. Then it says, he then travels at a constant speed of 10 meters per second, 200 meters due south. Now if going up is north, then going down is south. So going down would mean that he's going down. This is 100. This is minus 20, minus this, minus. Right here is 20, 40, 60, 80, 100. This is minus 100. So going from 100 to origin is 100 meter. Then going down, make another 100 meter. So he travels then to this point, to some point Z, because it says he goes south, you know, he went south. That's what south means, so he traveled down. So that's our displacement time graph. That's 5 marks. Thought it could have given 6, given that we had to do the calculations to find time. Maybe they could have given 1 more mark, but that's what they did, no problem. It says calculate the average speed of the journey. Average speed is total distance divided by total time. All right, so average speed is equal to total distance divided by total time. So the average speed, I'm going to call it V. Just going to call average speed V. The average speed V is equal to the total distance. We traveled 300 meters in total. 300 meters divided by the total time. I think it was 80 seconds. So its average speed is 300 over 80, which is 3 bills divided by 80 is 3.75. This is going to be 3.75 meter per second. That's its average speed. Now what's next that they ask? Find the average velocity. Now here's the difference now between average speed and average velocity. Average velocity is equal to total displacement over total time. That's average velocity. All right. That's how we find average velocity. Total displacement over total time. So let's go ahead and find the average velocity. Let's call it V again. V is equal to the total displacement. Now we're going back here, 100 meters in this direction. So the total displacement, you have 100 meters going up, then negative 200 meters. So it is 100 This is displacement. Displacement is 100 minus 200. So in reality, that's minus 100. All right, that's minus 100. So the displacement is minus 100 over 80. So the average velocity is minus 100 over 80 seconds, which is minus 1.25. Minus 1.25 meter per second. All right, nice and easy, soft. Now here's part B now. Part B is a particle starting from rest travels in a straight line with an acceleration a, given by a is cosine t, where t is in time, and it says find the velocity of the particle in terms of t. So we have to remember that if the acceleration is cosine t, velocity is the integral of acceleration. So the velocity is going to be the integral of the acceleration, and the acceleration is cosine t. When you integrate cosine t, you get sine t. So the velocity is actually sine t plus some constant. Now we need to find that constant. Let's call it plus c. Now, what is this constant? It said that it started from rest. So if the particle start from rest initially, when v is 0, t is 0. All right, so clearly the constant is going to be 0. The constant is 0 because it started from rest. All right, started from rest. So c is 0, and so the velocity is equal to sine t. So let's write that down. That the velocity v is equal to sine t. 3 marks for doing nothing. We gladly accept this 3 marks. Now it says calculate the displacement of the particle in the interval from pi to 2 pi. Now the displacement, to get displacement, the displacement is the integral of the velocity. So it's the integral of the velocity. Displacement s is the integral of velocity, and we're integrating from pi to 2 pi. Nice and easy. So when you integrate sine t, you have to remember when you integrate sine t, you get minus cos t. All right, minus cos t. So now we get minus cos t, and minus cos t, we're integrating from pi to 2 pi. So you plug in 2 pi first. So plugging in 2 pi, so the cosine of 2 times pi. So plugging in 2 pi, we're getting in minus 1 minus, when you plug in pi now, you're getting the cosine of pi plugging in the cosine of pi, I'm getting cosine pi is minus 1 minus minus 1 is 1. So the displacement is minus 1, which is minus 2 meters. All right, nice and easy. That's it, minus 2 meters. That's the displacement. Remember, displacement is negative. So what that means is that if you want to write it out in words, you can say that is the particle traveled 2 meters in the opposite direction from its start point. That is 2016 soft. So again, just subscribe, give this video a thumbs up, and yeah, see you soon in more videos. I hope you're having just as much fun as I am having. Nice.